folks who have joined us to hear John's talk about what he's been doing in South Dakota, which we'll be getting to that in about 10 minutes. But first of all, I wanted to cover a couple of things of our regular business, and that is to wrap up our discussion on the 2013 RFP, where we ended up as a committee for our recommendations on the final 14 projects. Ask anyone if you've got any last-minute comments for Ashley. She's been making editorial changes to the draft over the last week, and I'm sure she would take any additional comments. Correct, Ashley?
Yes, absolutely, and we will be releasing it as a draft next week, so if you haven't had a time to look at it, not to worry. There will be additional opportunities to make comments after that draft is released.
And then we'll turn this over as quickly as possible here to John, the Executive Director of Ecosystem Management Research Institute, for a great webinar that I'm looking forward to hear about the work that he's been doing, in particular in South Dakota, and how it relates to the activities of many of us on this partnership. So maybe just as a reminder to folks where we left our funding discussions going into the 2013 fiscal year. As you can remember, we had 3 projects that were funded last year that we were carrying into this year, and then we had 3 projects from 2011 that we were carrying into 2013, all of which provided a pretty significant funding tail for our budget this year. Since we last spoke, Rick and I have had some conversations with the USGS related to the pattern tile drainage project that they've been doing in eastern North Dakota and eastern South Dakota. They're having some difficulties with some of the contracting to get that tile installed. That's put a delay on that project. And so the last portion of that effort will not begin until 2014, which is allowed us to move that project into the 2014 funding tail and take it out of the 2013. But that still leaves 5 projects that we had committed to funding. The Vicki Drice project, Doug Johnson's project with oil and gas, Maureen Gallagher's project, Robert Gresswell's climate change work in Montana on native prairie fishes. That's the last year of that project, and the last year of the Sean Cleveland work on grass and bird conservation and working landscapes. But as all of you who have probably been watching the news these days, there's all kinds of fiscal discussions and debates happening in Washington, D.C. related to sequestration, let alone our continuing resolution, all of which is going to have some sort of an impact on our available funds this year. We're not sure what that's going to be, but I'm going to ask Rick if he has anything to say on that as I show you the final rankings for all your efforts on the proposal. So, Rick, anything you want to mention about where we're at fiscally?
Well, a couple things. First of all, we knew this year was coming with regard to the funding tail, and we knew that this year we would have a lot less money for new projects than we've traditionally had in the past, and that's that reality. That will change next year in an ideal world, which means Congress actually gives us a budget.
As you can see at the bottom of this slide, our funding tail for 2014 is about $330,000 currently.
Yes, and so this year our funding tail was about $850, but we got $752 because of the postponement of the tile drainage one. But under a continuing resolution, those of you who work for the federal government know that we are only allowed to spend a certain percentage of funds that we would have gotten. So our normal budget was cut down by 41%. And the other issue that we're going to deal with here at the steering committee is the fact that under a continuing resolution, we're not allowed to start new projects. And technically speaking, any of the projects that we've been ranking and reviewing now would be considered new projects. So toward the end of this discussion, we'll ask you for some thoughts on recommendations. I did meet with the steering committee co-chairs yesterday. Of course, Tom Melius, who's with the service, fully knows what's going on. We briefed Terry Steinwand on the issue of where we sit. So next week at the steering committee meeting is going to discuss how they would like to proceed with support of the ongoing projects, and then what do we want to do about the new projects. And that's, I guess, where we'll ask you guys to weigh in. There's a number of things we could propose, and the steering committee will be looking for those recommendations. We've got kind of a double whammy going because we also have Seacoast Strait coming up on the 1st of March. That adds another 8% reduction. And as I understand it, those two things can be additive, but we won't know what happens for a while. So we're faced with the fiscal reality of this budget crisis. Every other LCC is going through these very same exercises. I talked with colleagues in a couple other LCCs this morning, and they're doing the same thing that we're doing. They're ranking and reviewing new proposals. They're not sure how they're going to proceed. So unless folks have questions, we'll continue on.
So I guess my recommendation is to open this up for technical committee members to weigh in here on a recommendation that we should carry forward to the steering committee next week for their meeting Wednesday morning. This is where the proposals ranked out, and if there's a recommendation from the floor that would like to come forward, I'd certainly take that now.
Mike, this is Steve. I guess given the uncertainty that we're faced with as a service and as the LCC for funding, and not sure what the steering committee is going to talk about next week, it almost seems logical they should just go down the list, and if there's funding enough to hit 2 or 3 or 4 projects, that they just pull them right off the top. Is that kind of the recommendation?
Well, that's part of it, Steve. I guess I'd also entertain, a reconfirmation that our first obligation is to our existing projects that we funded in the past.
Well, I guess that was kind of a given the fact that we are limited on starting new projects. Those are going to be the first and foremost. They're going to have to be funded anyway because they're ongoing. So
the other thing we could consider here is if sequestration and the continuing resolution prohibit us from any new starts, do we want to carry these ahead 6 or 8 months, I guess, until October, and reconsider these with the $14? I guess that's something we could also propose to the steering committee. After we would recheck, I guess, with the PIs as to whether or not that would preclude this work from being done if it were to be put on hold for 8 months.
This is Larry Roberts. I would favor that approach.
Thank you, Larry. Anybody else?
Well, this is Kevin. If you can't start new contracts, then that's what's getting. I mean, your hand might get forced. And if that's the case, then you could take care of potentially your funding tail.
Yeah, we have some questions. I don't think the Doug Johnson existing work is a new contract. I looked that up, Rick. We do have an existing contract that extended into 15 on that. For some reason, that was the way it was written the first time. So I think that isn't going to impact anything that's ongoing, but it might certainly impact anything new. So, Kevin, are you recommending anything relative to these come October of this year?
No, I think the ones that ranked out were really good projects, and I'm hoping we have the ability to go forward with them. However, my point was just sort of pure logic, which is if you can't start a new contract, you can't start a new contract, and we can get rid of some of our funding tails so you don't have as much drag on the system in 2014.
This is Larry Roberts. Just to qualify, I was assuming that the funding tail would be handled, go forward with it this year as you proposed earlier. Meaning it would be handled first and then these others. But we're talking about, to me, these new ones.
Yep.
So just to kind of summarize, this is Rick. What I'm hearing, our recommendation to the tech from the tech team to the steering committee will be, we will take care of the ongoing projects first, and then we will see where we are.
Go through this list in the order that it's provided.
We'll present present the ranking and review and the recommendation on funding of the new projects, but understand that the decision on what to do with those will be delayed until next fall.
Potentially, unless stars line up in Congress to get their act together. Shortly.
Yeah. And then we'll chat with the PIs to make sure that they, and they know what's going on, but make sure that they would be willing to then hold off until next October. And then, of course, that also assumes, as we always remind folks, everything's contingent upon Congress, that we don't run this rodeo again next year. Everybody on that same page?
This is Dave Howder. Yeah, that seems pretty reasonable to me, too. Yeah.
Thanks, Dave. Okay.
I don't need to show this, I guess, but I had it in my slides. This is where the 17 of us that weighed in put the proposals. Where you see blank spaces, those aren't non-starters. That was just where there was a potential conflict of interest or a couple folks that didn't have a chance to go back and review the Souris River proposal. But I can send this list out if anybody's interested in that. I think what I'll do now is, unless there's any more discussion on that or anybody has any comments for Ashley, I'm going to turn this over to our guest, John Haufler. And John, what you'll see on your screen is a box in the middle that says Share My Desktop. And if you click on that, you'll have control of the mouse.
Wow. How about that? Can everybody see that?
Well, it's coming up, but oh, by the way, there's about a 3 or 4 second delay when you advance slides to when the group can see them.
Okay.
But I see your title slide there, and looks like you're good to go.
Great. Thanks. Well, what Mike asked me to do is present a webinar here on some of the work we've been doing with South Dakota game fish and parks. We've been working closely with Eileen and her staff on revising the South Dakota Wildlife Action Plan, and as part of that, incorporating climate change into that. Mike asked for me to share some of that information, so I put together a PowerPoint here, and need to acknowledge the work that Carolyn Mell has also done from Emory on all of this. So I don't want to spend too much time in the beginning of this. I'm going to be presenting this talk as well next week at the North Dakota chapter of the Wildlife Society meeting. So I put some information in there for targeting that group. But just pointing out a few things. For example, some of the more recent events, the conditions in Australia that are setting new records over the last month or so. Kind of fascinating that the first 8 days of 2013 were among the 20 total hottest on record. Rio hit a new high on December 26th. We've had the Middle East hit by rain, wind, and snowstorms with changing weather patterns occurring there. England and Britain seeing some of their wettest recorded years ever. And yet at the same time in Siberia, severe winter conditions this year that have been so cold that they've frozen natural gas or liquefied it in its pipes and left people without heat in those real extreme conditions. And then more closer to home here in North America, just some notes. The last 3 summers have been the hottest on record in Washington, D.C. 7 of the hottest 10 years on record have occurred in the last 15 years. Some studies have looked at when does leaf fall occur from trees, and it's arriving on average about 10.5 days later across the country. Spring is arriving 2 to 5 days earlier in pretty much all the states except for Florida. And as I'm sure everybody on the call is aware, 2012 was, for the U.S., the hottest year on record. So some pretty dramatic things already being demonstrated that are occurring with climate change. Related, Superstorm Sandy, while you can't necessarily blame that on climate change, certainly some indicators that climate change was helping intensify the effects of that.
So putting all of these things together, it's a little hard to sort of reconcile that with still some of the attitudes and all that are out there. For example, just a couple years ago, we had a state send a petition to President Obama and stating from their legislature that there is no convincing scientific evidence that human release of carbon dioxide or methane or other greenhouse gases is causing or will in the foreseeable future cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. Moreover, there is substantial scientific evidence that increases in atmospheric carbon dioxide will produce many beneficial effects on the natural plant and animal environments of the Earth. So that's a little hard to swallow given the evidence that is out there. And so I think one of the primary messages to provide to folks like wildlife biologists is that climate change is occurring. There is pretty much extremely solid scientific evidence of that, and in fact, many of the impacts we are seeing today are occurring at faster rates than model predictions. The previous model predictions have suggested. There is very strong evidence that this climate change is strongly affected by anthropogenic sources of greenhouse gases, and it's very clear that climate change can have and is likely to have some profound effects on wildlife and biodiversity. So the question then that I'm trying to make is how should wildlife biologists respond to this kind of information? What can they do? And I think the first recommendation for wildlife biologists is that we are a science-based profession, and we need to acknowledge that science. And we need to be going forward and letting folks know that climate change is real, and the effects of anthropogenic greenhouse gases on climate change are also real. Too often I hear folks that are still very wishy-washy on this subject. In fact, this week I am at the Society for Range Management meetings and heard one of the board members of the society here state that, well, this is still too questionable an occurrence for Society for Range Management to want to take any policy action on it at this point. So we have to get past this saying, oh, climate change, and then kind of laughing about it like it's not a real thing, and really put forward that this is real, it's significant, and it's having effects. Related to that, I think we need to be trying to educate others about the critical need for climate change action. That we really can't sit back and just wait and see what's going to happen in the next 20 years, because it's happening now and it's only going to get worse. So we have to try to change some of the naysayers' views out there and get things going in a positive direction. And to certainly support efforts to address greenhouse gas emissions. Now, I'm not suggesting that wildlife biologists can necessarily make that change, but certainly by promoting that climate change is real is an appropriate step. And then also there's other things that individuals can do. One of those, I found this article from a number of years ago in USA Today, and it was kind of amusing that the idea that we can offset away our guilt through carbon offsets and all. This article said, if we can do that, we can also do some other things like offset away adultery by providing funding to marriage counseling so that on an average you still maintain the proper number of marriages, or the Pilates offset where you could pay somebody for a gym membership so they could go and work off pounds, so that if you put extra pounds on, there's a no net gain in fat. Those are kind of comical takeoffs on this. Certainly carbon offset programs, while if you look them up, there's various concerns about whether they're effective and a lot of potential scams out there, but they do two important things. They do well-developed offset programs can help with carbon sequestration and the like. And more importantly, it brings the idea of we need to be be looking at our carbon footprint more directly home to people and potentially get them thinking about this and trying to take action. So those are some kind of action kinds of things that can be done. Further, as wildlife biologists, we have promoted within the Wildlife Society to take action on this, and the Wildlife Society does have a position statement on climate change that recommends that we need to mitigate greenhouse gases through these kinds of programs, that we have to increase wildlife adaptation abilities by enabling dispersal of species or the like. We need to be monitoring wildlife sensitive to climate change. We need to increase outreach activities to both biologists and the public about climate change, and include climate change consideration in all long-term wildlife plans. So these are all a good policy direction that the Wildlife Society has recommended, and that very closely parallel, of course, the National Fish, Wildlife, and Plants Climate Adaptation Strategy that came out a year ago that has similar kinds of recommendations of trying to make sure we're providing conditions to address climate change and support wildlife in the face of that. But coming back more specifically to how can wildlife biologists actually address more directly the effects of climate change? And a couple of ways that I think they can do that are to first of all try to understand what are likely climate changes that are occurring in their working areas, and to then try and interpret those to get a better understanding of what are the likely effects that are going to occur on plant and animal communities, and through that then develop proactive management responses to these effects. And that's basically what we've been doing with South Dakota Game, Fish, and Parks in looking at the revision of the South Dakota Wildlife Action Plan. In that, what we've been doing is looking at and incorporating information we can gather about climate change effects in South Dakota and applying that to South Dakota's Wildlife Action Plan, which is an ecosystem-based approach. The idea of the Wildlife Action Plan is to try to maintain the native ecosystems of South Dakota and have appropriate representation of those across the state. And then secondarily, looking at how the species of greatest conservation need fit into that provision of native ecosystem diversity. So it's a little different approach than what a lot of states have used in their wildlife action plans, where they start looking at the species of greatest conservation need and focusing on those. So what we did to address this was, first of all, we tried to get a better understanding of what's going on with local climate change in South Dakota. And we worked with Mark Cochran and his grad student, Chris Moran at South Dakota State University, and had them do some compilation of downscale climate change information for us. And we had them do that and characterize what predicted future conditions are going to be within the major land resource areas of South Dakota. Major land resource areas, probably most of you are familiar with those, but they are a Natural Resource Conservation Service classification of land areas that are characterized by particular patterns of soil, geology, climate, and water and land use. And so in South Dakota, we have a number of 19 or so different MLRAs that are either completely contained or come into South Dakota from neighboring states. And each of these MLRAs then will have a narrower range of climate and geological features and such than any of the others surrounding it. So we looked at climate change relative to what's going on within each of these MLRAs. The downscale climate change information relied on a compilation of the 16 global climate change models and predicted future climate conditions based on a low and a high greenhouse gas emission scenario. Generally, I'll present both of those scenarios, but in some cases, I'll just show some graphs for the higher greenhouse gas emission scenario. And I do that for two reasons. First of all, since we've seen so little action moving forward on actually trying to address climate change, that the lower scenario one is already being surpassed by current conditions. And secondarily, since we're seeing events that are occurring at faster rates than even generally predicted by the models, it would seem like the higher scenarios are the more logical ones to rely on. Some of the results of that climate change analysis for South Dakota, generally the models are predicting increases in both temperatures and precipitation. However, the average precipitation is generally expected to stay within the range of variability that's been observed since the turn of the century, the 1895 or so, while average temperatures will exceed those historical ranges. We're looking across the individual MLRAs. If we look out to the end of this next century and look at the high greenhouse gas scenario, we're expecting to see average annual temperatures increasing anywhere from 4.3 to 4.6 degrees Celsius, with summer warming up to 5.7 degrees. Precipitation is expected to be greater than 10 to 17% than the standard conditions that were looked at between 1961 and 1990, with some greatest increases in certain MLRAs being up to 31%. The precipitation findings, though, when you compare what was the climate normals from 1961 to 1990, we've already seen precipitation levels that have gone up over the last 20 years. Not so much in the northwest part of South Dakota, but throughout the rest of the state. And we've seen, in general, in the eastern part of the state, increases by as much as 10%, and 6 to 9 down to 5% in others. The models predict that in the future we're just going to see that same kind of general condition going forward, with a greater amount of moisture in the spring, in the winter, and drier summers. Now, whether that holds true or not, we'll have to see with events down the road, but that's kind of what the models are predicting. So when we look at average annual precipitation that's predicted to occur, and we look at the present levels of that, we don't see major shifts over the next 80 years or so. When we do, though, look at average annual temperature, we can see some dramatic expected shifts to occur as that some of the information provided. And of course, when we then consider what the combination of those, that each one alone has to be figured for that combination. That certainly evapotranspiration is going to be going up in the summer, and when you couple that with lower precipitation that's occurring, then it will generally mean reduced moisture availability during that season. Further, as predicted by climatologists, we can expect to see more and longer droughts and more extreme weather events. So put these together, rainfall in the summer, if it occurs in more intense storms, has higher evaporation rates and lower general moisture, we could see considerable moisture stress in certain times from that. So let's look at a couple of specific examples. I want to highlight an example. I've picked some information from 58B in the northwest part of the state, 53B in the north central part of the state, and 102A in the very eastern part of the state to highlight some of the climate change expectations. In the western part of the state, we've seen a little bit of a temperature increase over the last 20 years or so, but the predictions out there have it going up substantially over the next 80 years. We haven't seen much increase in the way of precipitation, and that's expected to hold true. So the combination there will mean drier conditions generally in that part of the state. when we look to MLRA 53B, we see a little bit of increase in temperature occurring now, with significant increases expected in the future. But we can also note there the increases that we've already seen in the precipitation in this part of the state over the last 20 years. But that's expected to pretty much stay fairly flat if the models are correct for that. Whereas in the very eastern part of the state, less of a temperature increase noted so far, but expected to go up, and the precipitation going up in the last 20 years, but expected to stay at those kinds of levels. What does all this mean? Well, I guess the other point here is looking at it, we've broken it down and have the information too relative to what's expected seasonally, and here looking at it monthly by precip, you can see the expected increases in March, April, and May, and not occurring during the summer and so forth. And same thing with the temperatures, substantial increases through the summer months. Also noting that March and November may become months that shift from an average below freezing level to an above freezing level as we get further in the century. What does all this mean to fish and wildlife and their habitat? Well, if we look at it relative to what might be happening with wetlands, we find two studies that we think have some interesting conclusions. Johnson et al. In Bioscience noted that it was apparent from their work that a 20% increase in precipitation would generally compensate for about a 3 degree centigrade rise in temperature if applied uniformly. Whereas Water Resources Bulletin article by Poiani in 1995 found that a 10% increase in total growing season precipitation was the only condition that would compensate for a 2 degrees increase overall in temperature. So if we look at those and say, well, what's likely to be happening with temperatures and precipitation predicted in South Dakota, if we look at where we are today in that 1990 to 2010, we can see that we've already increased in general across the state our annual precipitation, and that we're above those two predicted lines there, the Johnson et al. And the other line, so that we're seeing a net increase in the effects of precipitation with almost all of the state, with a little exception of those areas in the green below those lines. But if we look out from 2021 to 2050, we can see that we expect to see a pretty dramatic decrease in moisture availability compared to those lines, and it gets only worse as we go out further in the century. Even though right now we're seeing these effects of higher moisture levels, unless the models are wrong, which of course is a possibility, we would expect to see some real decreases in this moisture availability down the road. What will this mean for wetlands? We suggest that the current increases in precipitation will be offset and will result in greater wetland evapotranspiration, particularly in the summers in the future. The spring precipitation levels may be enough that if you can capture those waters when they have increased, such as in reservoirs and such, that we may not have wetlands adjacent to rivers and streams impacted to a great extent. And in fact, we may still see flood events and all like we've been challenged with in recent years. However, when we look at the temporary and seasonal wetlands, they may become particularly vulnerable to premature drying. The exception may be where terrain features allow for those temporary and seasonal wetlands to capture more of that spring moisture, but where you have terrain features that don't allow them to capture any more, we can expect to see those being substantially reduced. And in addition, with those higher temperatures we will see faster evaporation rate, and these could potentially impact our transitional plant communities that are occurring as those wetlands draw down. Another factor we noted was the average July temperature, and that's probably expected to go up more than just about any of the other factors that have been looked at. If we look at what the changes are from present, you'll note that we're currently hanging in between the 70 and 75 degree range, and predictions are that by the end of the century, this is at the higher emissions scenario, that all of the MLRAs except for the Black Hills could be above that 80 degree average July temperature later on in the century. What does that mean? Well, facing some interpretations from work by Fisher et al. In 2008, what they found was that if we look at the percentage of warm season or C4 grasses in the North American Great Plains, that they found that the percentage of either cool season or warm season grasses is highly influenced by that July temperature, and that a good mix, which is what we have right now in South Dakota, occurs in that 70 degree or so range where a lot of our MLRAs fall today. Below that range, C3 species, cool season grasses, will predominate, but if we get substantially above that, and keeping in mind we're predicting going above the 80 degree mark, that the C4 grasses are apt to become the predominant. What will that mean? Our current temperatures allow us to support a good mix of C3 and C4 plant communities. Throughout a lot of the states, those C3 grasses like western wheatgrass, green needlegrass, needle and thread, and others are the species that provide a pretty good structure, of course depending on the grazing activities that occur on those, but a good structure of that plant community for wildlife and other associated biodiversity. If we switch those communities to C4 warm season grasses, in the eastern part of the state, those will include species like big and little blue stem, Indian grass, and others, and we can still expect to have some pretty good grass structure where we can get those plant communities out there. However, in the western part of South Dakota, the C4 grasses that occur there are more moisture limited and are primarily blue grama and cytox grama, and they lack the structure of the current cool season grasses. So we can potentially expect to see changes not only in the composition but the structure of these plant communities. So how do we then apply this to the goal of South Dakota's Wildlife Action Plan of trying to provide for native ecosystem diversity? Well, first let me just give you a very brief background of how we're going about trying to provide for that. We look at native ecosystem diversity and we assume that it has several drivers. One is basically where the location is in the state based on MLRAs and those general climate and geological conditions. Within those, we then look at how ecological sites, the abiotic environment within an MLRA, varies, and then how do plant communities and associated animals respond to disturbances to those, trying to understand what was going on historically and interpreting that to today's conditions. So if we look, and we've used within MLRA NRCS's ecological site classification system. This allows us to look at the basic inherent diversity of the abiotic environment throughout an MLRA. It's largely a soil-driven system, but factors in terrain and a number of other features as well. And this provides us the information that we need to describe the native ecosystems of a site in terms of their composition and dynamics through state and transition models that are included in those. So with soils maps, we're able to show where ecological sites are and what are the expected plant communities that occurred there historically or could occur there today. Across that, we then consider what are the disturbance processes, looking at what was occurring historically with the role of grazing and fire and weather patterns, drought primarily, and how those shaped different plant communities. And then we can compare that to what's out there today. So, for example, we can pick a particular ecological site and we can look at what were the different plant communities that would have occurred on that site under historical disturbance processes, specifically differing levels of grazing pressure and time since fire in their interactions. And this just simply shows how the composition of species, western wheatgrass, green needlegrass, blue grama, and such, would be influenced by increasing grazing levels, reducing those species more sensitive, or time since fire, which over time with enough fires or lack of fires influences the ability of woody species to be present on the site. So this gives us a picture of what was going on historically and helps us understand what we potentially need to provide for plant communities that would support the wildlife associated with those sites. The idea, again, being that if we can provide for all of the plant communities that occurred historically, we'll provide the habitat needs of these species. Here's a slightly different example of a state in transition model for a clay site, showing also how we had what were the historically occurring states as well as today the non-historical occurring states that have been converted to other kinds of plant communities through various human activities. So that allows us to describe a reference condition, and what we're doing now is we did develop in the first Wildlife Action Plan a description of these reference communities in a more general way. What we're doing now is providing these on a web-based system where we can identify there what the desired plant communities might be for a particular ecological site. So a person can go in and look on the website in terms of what would we be trying to restore if we could do that in this particular location. Then we further evaluated what's the potential sustainability of that plant community under predicted climate conditions. We've linked then the species of greatest conservation need to those ecosystems, specifically those plant communities, and then that allows us to do a further evaluation of the risks to species of greatest conservation need from predicted climate change. So if we go back to that MLRA 53B, and this is a map of the ecological sites across that MLRA, and let's go in and zoom in a little bit on a location, and we can see the different ecological sites that are out there, and perhaps we're working with a landowner and they occur right here in this location. And if we wanted to work with that landowner and suggest what kinds of restoration work we might want to try to move that land towards, we can click on that site. And what will come up through the web system will be a choice. We can either look at it and say, okay, it's a clay ecological site. Do we want to know what plant community we're trying to restore? Or we can ask the question, what do we want to know about species of greatest conservation need that we might be helping through that effort? So if we click then on the restoration community, it will come up with a description of that reference community. Generally, we are, in most places, as a recommended restoration community, we're highlighting the lighter grazing kinds of conditions as those being generally the most out of whack relative to their expected historical amount. But in certain situations, we can select other plant communities as well. But in this case, we can pull up and it tells us what the different plant species that are associated with that site in that MLRA were historically. It allows us to look at and interpret which of those species are likely to be impacted by climate change, either positively or negatively. And we can then make some better informed decisions about what we should be trying to restore there if we want to maintain an effective not only composition, but trying to get at the right structure of that plant community as well. And it gives us some additional information such as fire return intervals and the like that we might be trying to incorporate in some of these sites. If we had gone to that same area and we were interested in knowing what's the species, the greatest conservation need associated with that, we can click on this site and get a list of those species that, by doing restoration work, we expect to be able to do some improvement to that site for them. So we might say, well, what's happening with Baird sparrows? We'll be able to go in there and pull up information that'll tell us about that species, what its historical and current ranges were, what does it need from a habitat standpoint, and what are the primary management concerns with this species. And obviously with Baird sparrows, it's a species that we would want to see that lightly grazed kind of high structure grassland community. Alternatively, you'll be able to go into the website and go straight to the species of greatest conservation need. And then if you pick Baird sparrow, you could go in and say, well, if I wanted to do something for Baird sparrow at a particular location, what would I do? And if you click on it that way, it will bring you back towards this recommended plant community that, if restored or maintained on that site, will improve conditions for that species. We can then look across all of the species of greatest conservation need, and while it's at this point, pretty well tied to just this potential shift in grass species and structure of the vegetation associated with them, we can at least predict what's likely to be occurring. Some will be positively influenced by climate change, and others are going to be negatively influenced. So we can start to determine which ones do we need to be looking at more specifically to address their habitat needs. How are we proposing to address these? Well, one of the things we're trying to do is map what we're calling terrestrial opportunity areas. We also have aquatic opportunity areas that are being developed through the Wildlife Action Plan. And what these areas, what we're trying to do with these is to identify areas that still have some of the most favorable existing conditions in terms of the plant communities, areas that are of known importance to various species of greatest conservation needs, areas that have public lands that we can devote to a conservation purpose, or areas where we know we have receptive landowners that can try and implement conservation opportunities. And then finally, one of the things we're trying to factor in to the extent we can is areas with minimum known development potential, particularly from energy and the like. The objectives of identifying these opportunity areas are we can then focus our conservation efforts in these opportunity areas, trying to get coordinated agency efforts in there, potentially trying to do things like increase incentive programs so that we can concentrate and try to develop some bigger blocks of grassland conditions than what happens if we just allow things to kind of go scattered wherever they occur across the state. And further, potentially what we can do with these areas is then try to work with industries to try to minimize the development impacts that are likely to be occurring in these areas, and starting to build them as important habitat blocks that we need to maintain to provide for species. When we get those maps, we'll also have to look at the connectivity zones and what that means, trying to connect some of these in order to provide conditions that will allow species to move, to disperse, and so forth among these. It's probably not too tough for birds. It may be more challenging to identify those conditions in connectivity zones that will allow mammals, reptiles, or others to cross there, but that would be a goal of these. To give you an example, I'm doing some work right now with lesser prairie chickens, and with that species we're taking a species approach to do the same kind of thing. Here is a current map of what we've called focal areas for that species, and we're also trying to identify the connectivity zones to do the same kind of thing, to build blocks of habitat where we can concentrate conservation efforts, try and engage industries to minimize development impacts in these areas, and hopefully allow these species to persist and have movement capabilities across the landscape. What we're trying to do in South Dakota is the same kind of approach, but not letting us get to the point where we have a species proposed for listing, but trying to identify and build the idea of these patches that we need ahead of time. So in summary, I think we all know climate change is here, it's real, and it will produce substantial changes. I'm encouraging biologists to take a bigger step forward and make response to climate change a high priority in the way they talk about it and the kinds of actions they are trying to do. I think ecosystem-based approaches, like we're doing in South Dakota, offer us a means of assessing effects of climate change on plant communities, and then through that determine what's happening with potential wildlife species. And through these kinds of new proactive initiatives, we hope that we can be more successful in moving ecosystem restoration forward. And with that, I'd be glad to...
John, thank you so much for a great presentation. I want to open it up to folks on the call for questions, but first I've got a quick one for you. You focused on the temperature changes during the summer months. I'm wondering if there was the comments you could make relative to the changes throughout the winter and as it relates to maybe sublimation rates and then filling of wetlands with less hydrology benefits come melt in the spring. Because it seems like we're really losing a fair bit of moisture with these winter changes that we're seeing as well, and shallower frost layer, and all that affects certainly the dynamics, I would think, of our wetland base.
I think those are very good points. It's not something we specifically address, but certainly when you look at particularly those March and November months and the changes in temperatures we're expecting to see there, those may be some real places where we see those kinds of effects occurring. The significance of that, I don't know, but it's a good point.
Questions for John?
Yeah, this is Kevin. I had a question on, I know when I was doing sage grouse stuff, folks were talking about the ecological sites to help manage sage grouse. Then we actually assessed it with occurrence data in the Powder River Basin. It showed that it wasn't a very good predictor of sage grouse occurrence because sometimes there's pretty large disconnects between what the sites could be and the structure they were actually queuing on. So I'm curious, in the plan, how much data do you have to quantify the relationship between the ecological sites and the different species that you're talking about?
Well, ecological sites, I think, are a very useful and powerful tool for understanding those inherent diversities across the landscape. They do not tell you what's out there under current conditions. They tell you, they bound what can be out there under current conditions, and they tell you what can be out there under current or under future conditions. And so they are very useful that way. The challenge when you do an analysis like you suggested, Kevin, of trying to overlay current species distributions to something like ecological sites, you have a very large amount of noise in those systems, from everything from mapping errors that we know are there in the system as any remotely fenced information adds those kind of errors, as well as just all the other influences that actually determine what vegetation is there today and how that species can respond to that. What I think is a better way of looking at this isn't just saying because you didn't find an example of a relationship directly that you could statistically show in one location between the species and ecological sites is to look at what do we know and can show from vegetation changes that we know certain ecological sites have higher levels of grass cover, different species of grass cover, different forb species, different shrub species, and the like. And where we know that those differences in vegetation occur, and we further know how those are related to the habitat needs of the wildlife species, that provides a pretty good indicator that those ecological sites can help you in determining management options and advantages for that species. So I would suggest that look at that as a stepwise procedure rather than trying to get through all the noise that's currently out there on a landscape through one straightforward analysis.
Any last minute questions for John? You've given us a lot to think about, John. I know some of us will get a chance to talk to you in greater detail next week when you participate in the North Dakota chapter of the Wildlife Society meetings, and thanks again for coming over to those. But I wanted to thank you again for this presentation today. It was terrific. Ashley was recording it, so we'll make it available to our members who were unavailable today, that they can pull it up on our YouTube site and watch it. Any last minute comments, Rick, relative to the steering committee meeting next Tuesday or Wednesday?
Only that after the meeting is over, Mike and I will put together the notes and fire them off to everybody.
All right, thank you guys again for a terrific hour, and we'll look forward to seeing some of you next week at the meetings. And John, thanks again for your participation today.
Thank you.
Thank you very much.